if you have an example, you can see what this nu really is. So the n plus 1, this is just the sample size, like our n sample size. It's nothing. But if you talk about this nu characterizes the growth rate, and that's going to be shown in the complexity bound. So nu is very important. But can you give an example now? I mean, why these two are connected? Here you take the maximum cardinality, and I mean over this thing. But it changes actually with your age. It's a uniform bounding. It's going to be simpler. You can give an example. Okay, next slide. Next slide. If you take the expectation to characterize the complexity, it's not going to be easy, right? Yes. That's the expectation. The right-hand side has the growth function. That's actually the tool we're going to analyze and complexity down. Okay, you have to think about it, I don't have time. Just move on.
Okay, so next I introduce the VC dimension. The VC dimension, first is the definition for the VC dimension. That means a hypothesis class H belongs to this set, and this shadows the S. That means the cardinality is equal to 2 to the dth power. D is the dimension. And what does this mean?
Very good.
Actually, first I don't. It's very hard to understand what's the meaning of the.
Yeah, it's easy to see. It's hard to understand. But you have been studying this.
I'll give you some examples to illustrate what's the meaning of this residuation.
Okay.
So maybe consider a real line and consider about a left left open and the right closed interval, and consider we have 2 points.
Well, before you talk about the result, can you just give some intuition of this H? What is H? What is X? Why we are studying this thing? This is in a classifier setting. I mean, it's better explained in a classifier setting. But if I were, I would say something about this H thing, this S thing also.
H is just the hypothesis set.
That doesn't really mean anything.
Yes.
That's just a word. What is your problem? I mean, the goal, the study. What do you want to study? What is the research problem?
We want to know, given a hypothesis set, because the hypothesis set is infinite, we want to find.
What is the use of this hypothesis set? You can't make any connection to real-world classification problems?
It's just a very simple classifier.
Okay. Don't really reminded you of this. Say it from the beginning.
Maybe like.
H is not some abstract thing, okay?
Maybe just for a classifier.
Okay. H is a classifier.
Yes.
Your H doesn't give me a classifier. You have to be more specific.
That to be an indicator of.
Yeah, finally.
Yeah.
We don't need other people to point it out this thing. You have to understand. If it's typo, I think it's okay. I can forgive this thing. But you don't really understand this thing.
This, if the indicator can be written as a smaller h.
I don't know what your smaller h is.
This.
I just want you to talk about the meaning so that people can understand you. People know actually why you're studying this thing. Right now, they just know there's some kind of H, weird H. Why do we want to study this H? Why do we want to use this H? What is the problem set up? Anybody who can help him? Anybody? This is pretty trivial, right? Just want to explain. Jiahui?
So H is kind of classifier. You are studying how complex a classifier is. It's like a straight line. So, like for your two examples, the first one you have VC dimension 1. It means it's not that complex. And the form is from negative infinity to some real number t. And you are studying this because you want to know how complex, which is related to the growth function.
Okay, that's the goal, but I mean, this is better because it's connected to a real-world classification problem. But let's say we have a classification problem, just one predictor, one feature, and the label is given by, I mean, whatever you call it. Maybe I just call like less than or equal to 0, then it's 0. Greater than 0 is class 1. And then I want to use some classifier to, do the classification. Of course, I don't really know the true rule. I mean, I give you the true, classification rule. And then I can use some candidate classes that estimate the t parameter to do some good classification, right? That's the problem. Of course, different, functions have different complexities, and maybe they don't really suit your job. It depends on how challenging the problem is. But there is a classification problem. I mean, the classification problem asks you to study if your classifiers are sufficiently complex enough, right? Because my classification problem, my labels could be made in such a way that maybe on some intervals it take value 1, the other will not necessarily connected, 0. Then is the first one enough? It's not enough. Why? Because it causes underfitting issues. It's not complex enough, so we need to categorize it. So now let's see what we can do. This is pretty simple. We just have one parameter. So similarly, you should have dimensionality 1. That is indeed the case using VC dimension. And maybe we can use a more complex classifier, still actually just one feature classification job. But now we have 2 unknown parameters. And then the dimensionality, see, is 2. This is pretty intuitive. But maybe it's still not complex enough. Who knows, right? I mean, this actually can be useful in categorizing the complexity of your classifier, as just we mentioned. Well, you have to make the connection. You have to use examples. You can't say you read. What you're basically doing is read from the first line to the last line. That's the worst thing actually. If you give a presentation on technical stuff, there are already so many symbols. You don't want people to get confused. You want people to understand that. I mean, VC dimension, growth function. These are extremely important things. Everybody actually in machine learning, doing theoretical research, is using it. It's not really that difficult. But if you can't even explain what is really useful, you just say, oh, there is a hypothesis. Hypothesis. What is hypothesis? Why? This has VC dimension 1. Yes, we saw actually a row there. Why? What's the intuition? Why do we have to study this complexity of H? Isn't just because actually, just as Jiahui said, we want to use such a class of classifiers. We want to estimate T to get the best one. Of course, now we don't really know T, but let's say how, if you choose T, then you're actually basically choosing from the indicator functions. The left hand side means minus infinity. The right hand is some unknown T. And that can give us some intuition, right? Go back to the definition. You just talk about some outcomes. You didn't explain anything about the VC dimension yet.
So I think that means the VC dimension is, and we have H, and we want to know the complexity of the H, and
you didn't introduce this growth function well, now you can only say anything. Okay, sorry, let me just give a comment. In your literature study or just reading the materials, the tutorials, I'm not asking you to show a proof actually, but the basic concepts, the basic notions must be understood. You must show some meanings. If you say, I don't even know what this definition, what this concept of what like this dimension, why is written this way and why it makes sense, then it's going to be useless, right? If maybe later I forget all this notation, but still remember, oh, this is the shattering problem. Maybe I can use my own notation to represent it, but still remember the exact meaning, or maybe it's just a rough meaning. That's going to be very helpful. The growth function, maybe you don't really know how to introduce this notation. Yeah, but just talk about what it means. You don't have to show the proof like from Mansell's theorem. Yeah, you don't have to. There are too many details. But you need to at least explicitly talk about the meanings of these concepts. That's the bottom line, actually. Okay? Can you explain anything about this VC dimension?
It's close related to the growth function of H.
Yeah. So
that it has been defined as when is the largest set that can be shattered by the edge.
that's all. Did you define what shattering means?
Shattering means, take this for example, if we have 2 points in the real line, and for this interval, we want to.
We go and use the example. If you say something.
If this 2 example, this is one situation, and this is another situation, and this is another situation. That means these 2.
I don't understand. You basically saying this is one situation, this is another situation. I don't understand. What is your setup? It's a classification. You want to shatter, you want to separate. You said this is the situation. I guess nobody can
What
understand.
cross means.
So this crossing means the point.
Well, you have to go one step further. When people ask you a question, oh, what does this, it's basically just saying the notation. So people ask you because they don't understand. You need to explain. You're not just talking about, oh, this is a point.
So what's the meaning of shattering? That means
Well, just do your example. You're using an example, but we don't understand your example.
given 2 points.
Okay, given 2 points.
Given 2 points,
And-
like maybe like x1, x2, these 2 points
Uh-huh.
in the real line,
What do you want to do?
and we want to separate these 2 points maybe.
What do you mean by separate?
What do you mean by separating these 2
What
points?
I mean by separate, that means given this interval, if one point is on
Interval. What is
What
this interval?
I don't think the interval is given. It's given something else. Then you use the interval to classify it.
given these 2 points,
Yes.
yeah, use this interval.
What is this interval?
It's,
Where is your age?
Find interval.
You should be in some kind of family, right?
Yeah, it's a
Yeah.
family
Yeah.
with variety.
Well, this is really, not very satisfactory because you didn't even realize the issues. If you realize the issue, that's actually already half done. But you didn't even realize it. You basically saying this, that, interval. There is no setup, there is no context, there is really no specific detail, there is really no problem. What do you want to do? What is your task? You said there are two. You said given 2 points. Okay, so what do you want to do?
And this is a hypothesis set.
That's right, but maybe give a clear thing. I mean, because now it's not very clear.
And we want
This is a hypothesis set, right? You said.
yes,
Okay, you want to?
we want to see if this hypothesis set can shatter these 2 points.
You are explaining
Yeah,
shatter.
you are explaining
You should
that.
avoid using the word shatter since you are explaining it.
So
I'll repeat what you said. Is that we want to use this hypothesis set to shatter these 2 points. This is already like the 4th or the 5th time you're repeating yourself. Nobody can understand it. Well, I have to say this is really, really important. You know, we have some students looking for jobs, but communication skills are extremely important. Say if you want to be RA, you want to teach a class, you have to practice this. But the worst thing is you didn't even realize these problems. You didn't even think from the student side. In some sense, actually, you have to just pretend you know nothing. And then you think, oh, they're asking me this question because, that's the thing. If you're smart enough, you should realize this already. So what is the problem? Given 2 points.
given 2 points, maybe we consider about a classifier. We want to know these 2 points maybe can be classified.
The 2 points will have 2 labels, and there are several
Yeah.
different cases,
Yeah,
and
that's
whether or
much
not
easier.
your classifier can correctly classify.
You consider a classification setup. Why do you want to separate them? Because they can belong to different class labels. So it could be much easier to say I have 2 samples. This class is is 0, the other is of class maybe 1. So if I want to do classification right, I need to somehow separate these 2 samples. If I'm using this type of intervals, that means my t should lie in between these 2 points. Any point is fine. But if I have such an interval, I can put the indicator function. If it's less than equal to t, then it's 0. Greater than equal to t is 1. Then it suffices. That's why we want to talk about this separation you just mentioned. So now let's talk about this. If this h of this one-side intervals are sufficient or not to separate these 2, because I could have different class labels for these 2 observations. So I want to separate them, right? Do classification. Is it enough? It is enough. As I said, actually, you can put any t in between, and then you can get 2 different class labels. But you have 3 points or 4 points.
If
you have 3 or 4 points, you're still not talking about this class label, you could be in big trouble. Think about it.
if this 2 point has different labels, then maybe we think this label is 1, this label is -1, this is 1, and we want to separate them. And for this hypothesis set, we have only one choice.
Only one choice. What do you mean? I thought it's infinite many.
The result of the classifier should be 3. They could both be 1, both be 0, -1, or the left one means -1, right one.
Well,
That's
the
3.
color value can be anywhere, in between.
Yes,
I think you first have to explain why here the VC dimension is 1 instead of 2.
Yeah.
Because it's actually 3, smaller than 2 to the power 2.
Give 3
Yeah.
points. Give 3 points. Then you can realize why I said you have to give the class labels. Dongwei also pointed it out. Let's say we have 3 observations. Is this enough? 3. Add another data point. Okay. So if you don't talk about class labels, you won't be able to see this thing. How will you assign the class labels? And then you can, just say in this case, this age, you can already separate, like according to what I, just want to.
I think giving 3 points, giving 3 samples, and for this situation.
Well, you're not really following people. You're not following people at all. Shao, Dongwei, including me myself, we're talking about this VC dimension for the first class of, classifiers. Shao said if you have 3 observations, then you can see why the dimensionality is only 1. I said yes, you need to add maybe put 3 observations, and then you can talk about the first, the one-sided intervals.
2 points are
I think for the first one, only 2
Yeah,
points.
why is
is
not enough? You have to make the class labels. You didn't give the class label. That's what people don't understand. Why I want to separate? 3 observations. Why you said the one-sided intervals, they can't really do a satisfactory job.
What if the one in the middle is different from the 2? Like 1, 0, 1.
Did you get that?
Yes.
Write it down.
So Dongwei means if this one is it has different label with
Can you
this
write it
one
down?
too. Maybe like this.
Okay, now, with these class labels, you can talk about this separation of shattering more explicitly.
This cannot be separated.
Yeah, but there's a missing link. If you want to achieve perfect classification, what kind of separation do you desire?
We want to completely separate these 3 points.
You're not thinking. You're just. Okay, Sean, go ahead. Go there. Talk about this example. Point to it. Listen, okay, please.
So first, why here is 2 to the m is very important. It has to achieve fully maximize, fully possible class label. For example, there's 2 points here. I can have 0, 0, just 0 and 1, and 1, 0, 0, 1, and 1, 1. And if we use an indicator function from -infinity to t is any number, you can do this, but then you will have only 3 outcomes. For example, if I say here smaller than this t is 0, and then larger is going to be 1, you will have 0. And if I, for example, first I can from here, t is here, then here is 0, here is 1. So you achieve this one. So both nodes, both points will be classified as 1. And then if I move my t to this place, you will achieve this because this is smaller. The first point, is there any other? Anyway, I will just put 1 here and then this node 2. First node will be classified as 0 because it's in this interval. Second point will be classified as 1. So it achieves this as well, first as well. And then if I further increase this t to be here, interval here, then you see we can achieve this because both points now fall into this interval. So now this is also fine. But then you find there's no way, no matter where you put this t, you can never achieve this 1-0 classification. So the total outcome, the number of outcome is equal to 3. And then 3 is actually smaller than 2 to the 2, power of 2. So you know it cannot shatter 2 points. And then for 1 point, it 0 and 1, right? You have only two labels, and then I have -infinity to t, I can put t here, you achieve 1 because the node is larger than t. But if I put t here, you achieve 0. So both are classified. I mean, both label can be achieved. So this is like 2. The outcome is 2, and then it's actually equal to 2 to the 1. So you know this VC dimension is smaller than 2, and I can find one point that basically means fully shattered. It means you can actually achieve perfect classification where you can achieve both class labels. Therefore, here is actually 1 for the first case.
Okay,
not
let's
2.
for the 2 sample case, I mean 2 to the 4 classes. They explain the 3 observation case is insufficient.
Still use the first.
Yeah, it's the first.
So if I have 1, 2, 3 here. So first is still this line, and then you can, what we know there's actually totally 2 to the 3 possible labels, which means you have 1, 1, 1, and then 1, 0, 1, 1, 1, 0.
You just like choosing a subset,
Yeah, and then
and the complement is the other.
yeah, and then we try to see if we can actually, basically what we mean by shattering, if we can actually achieve all 8 possible outcomes. And then we still use minus infinity and then t.
Use Dunri's example, 0, 1, 0.
Yeah, we can directly see, for example, 1, 0, 1, 0. Yeah, this example. So if we put t here, this 0, this 1, right? But this is also going to be 1 because these 2 points are guaranteed on the same side. So you cannot put t here. And then if we try t here, then you see, okay, now this point, these 2 points must, even if you flip the interval, these 2 points must have the same label because they are 4 in the interval. So which means this kind of, and also 1, 0, 1, these kind of outcomes, you can never achieve that. That means these points like this 3, it cannot be shattered by this hypothesis.
Very good. So I have to say, actually, maybe he didn't express himself very clearly, but I think everybody can understand. It's not really because of English. It's not really because of his thinking. He's trying to convey the right things. Well, you can't really repeat the sentence or the notation when you teach something. That is the point. So maybe I don't really speak good English. That's fine. Nobody's really that picky. I mean, I know actually people need to practice English a lot. But in Shao's case, it's a perfect case. I mean, you don't have to have perfect English, but still you can talk about people what the ideas are. You have 2 examples, 2 samples, 3 samples, then you can understand what is shattering really mean. We don't assume any distribution, by the way. Okay, you can see actually you can cover all the possible. Well, the classification here is 2 class classifications. I use a subset for 1 or 0. The complement is 0. I mean, corresponding 0 or 1, right? So if I want to say this class of classifiers very powerful, then you should be able to classify like this, all of these different situations. So in some sense, I already see the non-parametric flavor actually. Of doing this in the pipeline. It's not really like a statistic. We assume there's some distribution, usually, not nowadays actually. We usually assume some distribution, and then based on the distribution, we derive something. This is classification. Classification sometimes can be done in at least more non-parametric way. And that can help you explain the shattering thing, but you define it using a growth function. I don't know actually if you can make a better explanation of the growth function now, but I guess we'll have to move on. The shattering has a lot to do with the classification. You have to talk about this classification context. Otherwise, so.